afternoon, brother. How you doing?
Pretty good. How you doing, man?
Pretty good.
Good.
How's life as a grandpa treating you there?
No, it's pretty good. We had a birthday party for the grandkid this weekend, so it's pretty good. A lot of his relatives were there, and
Nice.
Nuclear power may be our best option as far as providing clean, GHG-free emissions due to its lifetime and life cycle considerations.
We've talked a lot about stuff over the years. All different types of power plants. We've talked about, solar, wind. We've talked about, the nuclear plants, clean burning coal, natural gas. There's the hydroelectric plants. There's all kinds of power producing plants. What do you think is your, if you had to pick one to say, this one would be the best overall for efficiency and good for global warming,
green. Well, as far as right now, I think it would be nuclear, though.
Nuclear?
Yeah, I think it would be nuclear, and obviously there's safety concerns.
I think we both talked about that in the past, right? We think nuclear is one of the things that could really save this planet, is to do more nuclear power, because once you get them going, the greenhouse emissions are basically very, very small, and so there's a life cycle greenhouse gas emission equivalency you'd have to factor in, but if you run the plants for a long time, which they can run for a long time, you're talking about a pretty green energy producing situation there. But I agree with you, brother. I think the nuclear situation could probably make a lot of headway for us in making green energy. Now, you've done a lot of research on nuclear plants, lately. When we think of nuclear, we think of these big facilities, heavy water contamination, all these things, right? Is that what we're talking about now, or is there something new online that's coming up that's maybe better?
Yeah, there's alternatives to these large nuclear plants. There's things called small modular nuclear reactors, and that's something that has a lot of advantages to it.
Small modular nuclear reactors are ideal for various industries and data center applications where these specialized facilities require 24 hours, 7 days a week, constant power.
So you can have them in a lot of different applications, for like industrial. Weren't you saying something about like data center?
That's a good point. I mean, you could, a lot of data centers or a lot of industrial businesses, like aluminum factories, other factories that make and manufacture stuff, steel mills and stuff, they build their own power plants because they consume so much power. And a lot of times they're coal or natural gas plants, maybe more natural gas plants these days. But now that you're thinking, a nuclear power plant? That's no way. But now with these small modular ones, that's a possibility now. These companies can each have their own power plant. That's nuclear. That's green producing energy right now.
Yeah.
And what's good for those data centers and stuff? Data centers, cryptocurrency, all the AI stuff, the server farms, all that kind of stuff. They run 24/7 also, and so does a nuclear plant. They don't ever shut down. They just run all the time. So that would be a nice match, wouldn't it?
Small modular nuclear reactors have passive design systems which allow for automated self-regulation with many design improvements for efficiency and safety reasons.
What's another advantage of these small nuclear plants? Are they safer than the old ones? Because when we talk about nuclear, we go, 3 Mile Island and Chernobyl, and people get all scared. And so are they better than that?
I think they are, because they have like passive design systems.
Right.
So they're much more safer. So in case something goes wrong, too much heat or pressure, they can self-regulate, and they can automatically run to adjust to the situation. And it can be that way for several days or weeks before backup power comes online.
So we don't rely on like Homer Simpson to pull the lever, at the nuclear plant or anything like that.
Yeah.
Well, that's good. Yeah, you have several points that they could cool the reactors down after shutdown to prevent overheating. The passive systems, they have automated pressure relief valves, like you're talking about. They have self-regulating reactor cores, which is nice. And we'll talk about high pressure failures.
Small modular nuclear reactors that are liquid metals or molten salts create less of a waste disposal and radiation leakage problem when compared to liquid water cooling.
They use something called molten salt or liquid metal coolants. That's an interesting concept because most of these are like water coolant systems. Some of the bigger ones and things. So that's pretty interesting. I mean, maybe there's a big advantage to safety on that. You think? What I'm thinking off the top of my head is that when you talk about the radiation leakage or waste disposal from a nuclear plant, because the water is going to get contaminated. That's whatever cools down the reactors, they're going to get contaminated. And so you even have a closed system, you recycle the water, you need to dispose of it. And you also have leakage. And so my understanding is from these these molten salts produce less of a leakage hazard or a waste hazard. And so when you have to dispose of, there's less of a transportation problem. There's seepage problems that are less. And then there's less of a chance of escaping and re-radiating it out, I think.
Small modular nuclear reactors can utilize a variety of fuel sources that include uranium and thorium, as well as triso fuel.
What kind of fuels do they use in these small modular systems?
They can use all different types. Most of them are uranium based, but they can use like a combination of thorium and uranium, and some can use just thorium, I think. And they have different. Yeah, there's different types of uranium ones. There's like a uranium hydride type, and there's something called triso, which is
triso.
Yeah, triso fuel. So and that one has uranium encapsulated with like ceramic and carbon around it. And so these are good for the self-type regulating reactors. So they can adjust to situations easier they can adjust the power output and all that,
U.S. government labs are working towards solving the problem with the bad performance of metal alloys in nuclear reactors using molten salts.
I've also heard that because of the molten salts and stuff, they corrode a little bit, the metals. And so is that a problem you think that might happen for some of these plants?
Yeah, the type of metals they use can make it worse. I heard what happens is they can get kind of brittle and they can crack or something like that if there's too much heat with the molten salt. So that's one thing that they have to solve right now. In fact, I think one laboratory working on it is Oak Ridge in Tennessee. And so they're trying to build like this molten salt reactors that use a combination of uranium and thorium. And so the problem they're running with now is the materials type to use. So like they can use like combinations of nickel and chromium.
Well, that's good. I mean, that's nice. That might raise the costs a little bit as they try to solve some of those problems. At Oak Ridge, using some of the alloys and things. But that would be good if they could, and that way it'd be less of a maintenance problem with all the corrosion and that might happen over time, and the brittleness of the metal and cracking and things. That could be dangerous. So that's great. I'm looking forward to seeing more and more progress on these. I think there's some companies that are building them now, right? That are trying to get some going. So we wish them success. That's the future then. All right. Well, Phil, until then, we're the Climate Change Brothers, trying to bring you all kinds of information about what could make the world a better place and bring us some green energy. So
excellent.
Until then, we'll see you later.
All right.